In this video, I want to walk you through project 1. I want to walk you through every step because there's some new things in here, but there's some things you should be a little more familiar with. But as I walk you through, I want you to execute. I want you to think through and understand each step as we go along. Now the project here is we're going to be looking at elevated lead levels in children in Allegheny County, Pennsylvania. As you'll read for Thursday, lead toxicity is a major public health threat, particularly to children. It affects their cognitive development and can affect other health problems throughout the life course. Lead toxicity can enter people through lead-based paint. We used to use a lot of lead-based paint prior to the 70s and 80s, and once that starts to chip and dust off, it can enter people. It also was used in gasoline, leaded gasoline. You'll still see leaded and unleaded gasoline pumps, and also industrial activity and so on. So, it's in the environment, and it has had consequences for children in particular. So what we're going to want to look at is where elevated cases are in Pittsburgh, Allegheny County, Pennsylvania, and see if there's, if that's our outcome. One question we're going to ask is, does it vary by place? Are some neighborhoods disproportionately affected by elevated cases and some are lesser affected? So we're going to be looking for spatial variation. And then the other thing we can look at is the characteristics of neighborhoods that are affected. We don't have data on the characteristics of the children themselves, but we can get data on the characteristics of the neighborhoods that have higher or lower rates of affected children. Okay, so we can do a kind of a number of things with the data that we have here. So the first thing I want you to do is click on the yellow folder in the VLab, go to the Students Drive, Class folder, and there's a GIS Project 1 folder. You're going to want to right click and copy that, and then go to your Students folder and paste that in there. And so this is data from 2000, so I want you to use the shape files that are in this GIS Project 1 folder. Don't use the shape files from the AAA GIS data. We'll use those for transportation, but for the tracts and so on, use the ones in this folder. That's why I want you to copy and paste the whole folder and just operate out of that folder once it's in your student folder. Okay? So once we're there, we'll open up ArcMap. Now while we're waiting with ArcMap, I want to sort of give you an overview again of what we're going to be doing here. We're going to be constructing a data set of census tracts that are in Allegheny County, Pennsylvania. Okay? So that'll be the set of cases. To those tracts, we want to join census data, and we also want to join data on the number of affected children. Okay, and those are two separate data sets that we'll have to join in. From there, we'll learn how we can do a little formatting to sort of illustrate what's going on visually, but we'll also be able to take that data and bring it into Stata to analyze it sort of graphically through scatter plots, but also some correlation coefficients. Okay, so I'm just going to start with a blank map, and we're going to go to Add Data. So again, this first stage is going to be just drawing on sort of essentially video 4, the cookie cutter method of getting tracts in a particular boundary. Now again, I want you to be operating out of that folder that you saved, not the main one, that you saved to your own folder. And so we're going to bring in counties. I'm going to zoom over here to Pennsylvania, and if you want to label the counties, there's Allegheny, Pittsburgh here. Right? So we can then, if we want to already ignite that one, there's our cookie cutter. Okay. Now we're going to go back, add in the census tracts. Tracts looks a little different, it's just a slightly different version of a shapefile, so we'll just add those in. It still works the same. So we've got a cookie cutter. There's the tracts we want out of the larger tracts doe. So we're going to use the selection by location method and get tracts that are in the counties, but only the one that's selected. And then we want the centroid, the last one. Okay. So we've highlighted the rows of data or the polygons we want, and we're going to peel those tracts out of their doe, which is the tracts doe. Right click on tracts, data, export data. Make sure this saves to where you want it to. I just save everything back to that GIS project folder. And I'm just going to call this all tracts, shapefile, and hit OK. And add that and get rid of the other ingredients. Okay. Now one thing we didn't cover, but there's a video on this, but I'll show you real quick, is again, one of the sources of lead in the environment is old housing, which we'll get to with census data, but also transportation corridors where there was a lot of emissions back when we had lead in gasoline, but also industrial activity, which is also indicated by transportation corridors. So what we can do is we can go and add in those sort of references. And I'm going to click up and get to our AAA GIS data, and here we're going to use the transport information. I'm going to bring in both of those. Okay. And you'll see that they look like threads that just sort of span the US. What we're going to want to do is clip those off at the boundaries of Allegheny County. So we're going to go to Geoprocessing, and we're going to clip. Okay. And the input feature is what we want to clip. I'm going to start with interstate. The clip feature is essentially the pattern around which you want to clip. That's our tracks. Notice the output where it's trying to go is someplace crazy. Even though I see my name, don't trust this. Okay? Click on the folder. Make sure it navigates to where you want it to go. I'm going to call this int clip for interstate clip. Save it as a shapefile and hit OK. Takes just a moment, but eventually you'll see a little clip feature pop up in the bottom right when it's done. So again, just imagine taking a scissors and clipping these threads off at the boundaries of your pattern. That's what essentially it's doing. Now it added it. I can click on that little line and make this a little more noticeable. And I can get rid of the old interstates. So right click and remove. Okay. Now I can do the same thing with the railroads. Clip feature is our shapefile. Again, trying to save someplace weird, don't let it. Okay, now it's going to where you want it to. Call this rail clip. Hit OK. And that one did it. This one I'll click and put those to railroads. Okay. And then get rid of the old one. So now we got a little reference. Okay. Now, as you know, the attribute table for our tracks, this is what we're going to want to add variables to. So this is part of the data set construction. We got just the cases we want. There is some data in here, but we're going to want to add more data. But you'll notice there is no FIPS2. So one of the things we're going to need to do, unlike your previous experience, but which is reflected in the videos, is we're going to need to reproduce FIPS as a numeric version of itself. So I'm going to add a field. Call it FIPS2, set this to double, hit OK. Scroll across, there it is. I'm going to just click here to highlight it and then right click in Field Calculator. And FIPS2 equals FIPS. Okay. Now one of the other things that we can do at this point is we're going to be bringing in data on the number of kids who have elevated blood levels. So we might need a denominator of the total number of children in each tract. And we actually have that in terms of here's the number under age 5 and then 5 to 17. So we want to add those to get the total number of children. So what we're going to do is add another field. I'm just going to call it kids and double. And we'll right click and Field Calculator. Not FIPS, get rid of that. So kids is going to equal under 5 plus 5 to 17. I'm just double clicking to put them down there. So there's the number of kids, okay? And then I'll close that down. So now we need to add data, add variables to these census tracts. So I'm going to go ahead and add census data. I'm going to make sure I'm navigating to my own thing. There's the census 2000 CSV. I open it. I see that it's got the FIPS, which is going to match up with FIPS2, the population total, white, non-Hispanic. So you have a % white, non-Hispanic, black, % black, median household income, median year built. So both of these are medians, so they're the point at which half the households make more, half make less. It's the point at which half the housing stock was made before that year, or after. And then I've got the poverty status of those who are below the poverty line, and thus the percent impoverished. So we'd be mainly using the percentages and the median values in our maps. Okay. So we need to join that data to our tracts. So we're going to always join to the shapefile. So you right-click on your shapefile, go to Joins, Relates, Join, go down to FIPS 2, and then it reads and hit OK. So that data joined. Now we also need to add the data on elevated cases, and there's that data. If I open it up, it's got a FIPS, that'll join to FIPS 2, and these are the number of children in each tract that have elevated status. Okay, so we're going to also join that. Right click on your census tracts, and we'll go to a FIPS 2. It's reading elevated cases and hit OK. And so now we've got all of our data collated. So there you've got, kids, your census data, and the number of affected children. Okay. Now, if we want to, at this point, we can create a variable in our shapefile that is the rate of affected children. So we could do an add field at this point. I'm just going to call this pklead for percent of kids with elevated lead level. And then scroll across, ignore the all tracks thing, that's just an annoying little feature. Right click, field calculator, and that is going to be 100 times, and you want to do the number of cases divided by, careful not to get the FIPS, we want the actual cases, so ignore the FIPS one, over the total number of kids, which is right there now. Double click on that. Okay. So that's the rate of affected children in each tract. Okay. So at this point we want to bake all of that data in there, so we're going to just right click on the shapefile itself and export it on itself. Make sure it's saving to where you want it to save. I'm going to call this final data. And hit OK. I'm going to add that. I'm going to get rid of all the old ingredients, except the roads and interstates. So there's your map. Now one thing you can do at this point is to right click and copy on your shapefile, go up to layers, right click and paste layer, and just paste a few of these things. Essentially you're just reproducing that data set a few times over. Okay. So in this first one, what we can do is go to symbology and quantities, and we can just look at the rate of affected children. Now notice that pklead got moved up. Not sure why it rearranged it, but we can just click on that. Let's keep things simple and just go with 4 categories and hit OK. So you can sort of see where the higher rates are, right? These are the percent of children in each tract that have elevated blood lead levels. Okay. I'm going to uncheck that one. If we go to the next one, we could compare that to, let's look at percent Black non-Hispanic. Let's look at 4 categories. So you can sort of see the racial segregation in Allegheny County. Again, if we wanted to look at how that compared to the lead, you can just kind of toggle back and forth by checking and unchecking pklead. Okay. And the third one, let's make that one median, let's do percent impoverished. Let's just do 4 categories. Again, I have to uncheck the ones above it to see it. So there's how percent impoverished looks, or poverty rate looks. Okay. Again, if you want to look at how that compares to percent Black, check the percent Black and not, kind of go back and forth. Same thing with the pklead. You can see sort of visually that there's a little bit of a correspondence there. This other one we can look at median year built. Now again, oh, sorry, that was MHI. Median year built. You can see that a darker category equals actually a younger housing stock, or a more recent housing stock. So one of the things we can do is flip those symbols so that older housing stock is darker. Let's go to 4 categories as well and hit OK. Again, I can't see it until I uncheck things above it. So that's where the older housing stock is. And you can do the same thing for other things. Okay, so that's where you can get all your data. Now, one other neat thing you can do, I'm going to copy this again. Instead of a choropleth map, which is the sort of shaded graduated colors, you can do a dot density, which is a slightly different way of looking at things. So instead of graduated colors, you go to dot density and go down and click on EBLL cases and arrow it over. You can barely see the dot here, but if I click on it, I can change it to a better color, bright red. I'm going to have each dot size 2, I'm going to have each one equal 4 children. And go ahead and hit OK. So now you sort of see the actual cases, each dot representing 4 children. And now these dots are randomly distributed in their respective census tracts, so don't think that they represent exactly where children live. But you can actually see the cases laid atop, in this case, median year build. If I were to switch this to percent impoverished, then you can sort of see it like that. Okay? So one of the things we can start to do at this point is sort of format the data for exporting it as pictures. So I'm going to rename some of my things. To rename these things, you just do two slow clicks, and then you can just rename things. So I'm going to do 2 slow clicks, and then interstate. For this one, I'll do EBLL cases. For this one, I'll call this one EBLL rate, because again, this is just the actual number of cases, or represented the number of cases. This is the rate of affected children. For this one, it's percent black. For this one, this was percent impoverished. Again, you can see that I'm just naming them after whatever, however they've been formatted. And this one, median year built. Keep it short. Okay, and you can do that for other ones as well. So now what we can do is we can start to export these maps. So I'm going to click on this very small icon. It's the second one in on the bottom here. You can sort of see where I'm flashing here. Click on this little icon and you get to this page. And I'm going to just zoom in as tight as I can on Allegheny County. Maybe set this to 100%. There. Okay. Now notice when I did that, it kind of changed my dots to each one equals 6.7. I'm going to switch that back to 4. Okay. So now what I can do is I can, if I want to also insert a legend, notice that it's got every piece that I've got checked. So one of the things I'm going to cancel that. I'm going to uncheck everything except what I want. So let's say this is percent impoverished. I am going to then go to insert legend. It's got the 4 pieces I want. I don't need to call it a legend. I'm going to get rid of that. And there I go. So I'm going to put this down here. And it looks pretty good. There's a little bit of mess in terms of I don't want ppov in there, and I don't like all these decimal places. So one of the things I can do is I can go to ppov over here, 2 slow clicks, and backspace, and get rid of it. Okay. Now to get rid of the decimal places, I'm going to double click here, go to label, and format those labels. Right now it's already a percentage, represents a percentage, numeric options, and set that to 1. Hit OK, and hit OK. So now things are looking pretty good. The only thing I can't help you with is getting rid of EBLL cases right here. It's a little bit extra, but unfortunately there's no way to get at that in here. So maybe move this legend as close to the map as possible. So now I've got a map of percent impoverished. I can file and export that map. And I can call it, make sure it's saving to where I want it to. I can call it percent improv. And a TIFF file works great because those are a little more refined than JPEGs or PNGs, but those work as well. And hit save. And then you can insert a TIFF or a PNG file in any sort of word processing document, like a Microsoft publisher or something like that. So it gives you a little bit of control over what you're looking at. If you want to see, these dots a little bit better, you can try making them. What if I can change that to 1.8? Because sometimes you don't want the dots to get in the way of seeing beneath them. And that might make them too small. So one of the other things I can do, maybe 2 is best, but maybe you want to go up to 6. Or maybe even higher, right? Go up to 10. So you can play around with the formatting a little bit so that you don't lose the ability to sort of see past those dots, okay? So once you're done with that, what you can do is obviously switch this to meeting your build. And notice that the legend is off, so what I'm going to do is just delete it, and then I'm going to reinsert the legend, go through this whole process again, move it down here. And again, all I have to do here then is get rid of this meeting your built, 2 slow clicks, backspace, and you're pretty good to go. And so then you can file, export, went to 120%, about that. Everything else looks fine, and then you could, file, export map, and make a need your build. Okay. And once those TIFF files are in your folder, you can go ahead, and if you've shared your folder with your own computer, you can copy and paste them and go to your own folder. You can get into Chrome and go to your Gmail account or whatever and mail them to yourself, that kind of thing, if you want to operate on your own computer at that point. Okay. Now, one of the things about this data that we constructed is that it's got all of the data we want. Now we can actually analyze it statistically or graphically as well. So what I want you to do is minimize. You can open up Stata, and we can actually import that attribute table. That attribute table is a DBF file, a DBase file. So I can file and import. It's not file open, it's file import DBase file. And I can go look for it. Remember we called it final data. Let's go to students. And there's the final, that's the attribute table of our final data set. And we can hit OK. And there's all of our data. Okay. Now I'm working on a do file that you can use, but when it's ready, what you would do is just click on this little icon here, and then go to open a do file. And I'm making some slight adjustments to it, but what you'll be able to do with this do file is it'll be in the GIS project folder. We don't actually, first of all, we can rename the variables so that they're all lowercase, and that's just the command there. So you can just highlight this command and hit execute, and it changes all of the variables to lowercase. Now we actually don't need to generate these percentage variables because we already did that, or they're already in the data, so we can ignore these commands. We already created an affected rate, so we can ignore that command, but we can get summary statistics. So we can run that command, and you can see that there are 413 census tracts. The average rate of affected children across those tracts is 2.78%. Standard deviation of 4.3, but the highest is 24% of affected children. Some have 0. There's the percent African American, percent impoverished, and you can add in, if you want median household income and stuff like that. If we want to look at the correlation coefficients across those, so how are the affected rate compared to percent black? You can see that it's correlated at 0.66, which is positive and rather strong and high. It's correlated with poverty at 0.52. Now the correlation coefficients can only run from -1 to 1. Anything closer to 0 indicates less of a kind of a systematic relationship. Anything that's closer to -1 or closer to 1 in size indicates a stronger sort of systematic covariation, if you will. Okay. Negative just indicates that as one value goes up, we tend to see a decrease in the other, which makes sense with median year build, because as you get into more recent housing stock, you should see a decrease in the elevated lead rate. Okay, so that's the correlation coefficients in the commands, and then you can also look at scatter plots. Edit, undo. Here's how you would do a scatter plot between the affected rate and percent Black non-Hispanic. Okay. And then if we want to clean this up, we would click on Start Graph Editor up here. And then, the problem we get with all these damn decimal places is I'm just going to highlight that area and then go to Axis Properties and Label Properties. I'm going to go to Format, and I'm just going to do fixed numeric, and I'm just going to set this to 1. See what that does. Much better. Okay. So again, all I did is I clicked on that, set it to fixed numeric, set it down to 1. I think I could set it to something else as well, and that'd be fine. Okay. This one, you can click on this one then. Once that all lights up, just right click and go to Axis Properties, Label Properties, same thing. Do fixed, and let's see, hit apply, and it cleans that up. Okay. Now I don't want pklead, so I'm going to just click on that, and then up here I can change it to rate of elevated status. And then down here I can change this one to percent Black. Okay. And then if I want to give it a title, I can go over here and click on title and say rate of elevated status against percent Black. Okay. And if I wanted to, call it graph 1, or I could put it in there, graph 1, something like that. Oops. If you make any changes, you have to hit return. So like that. Okay. And once you're done editing, what you can do is stop the graph editor, and you can go ahead and save it. It's going to save as a GPH file, which is fine. We'll call this EBLL Black, but it'll still be up. And then what you can do is just save as at this point, and then you can save it as a TIFF file, and you can call it EBLL Black. If you want to call it the scatter, you've got that then as an ingredient in an analysis. Okay? So that's how you can do some of the analyses. Now I'm going to clean up this do file a little bit. It's got some stuff in here that I don't want, and I'll get rid of it. But you just need to kind of go through and execute the commands, and we'll talk more in class about what we're seeing in these kinds of things. Okay.